Hello Chem 1A, this is Chapter 10, Lecture Video 1, and we're going to be talking about in this chapter molecular structure and bonding in molecular compounds in most cases. So we're going to learn how to draw structures, we're going to learn about the shapes of molecules throughout the rest of this chapter and the next one. So we're going to learn a little bit, we're going to review bonding a little bit in today's lecture. And talk about some of the symbolic ways we can represent how many electrons, valence electrons, an element has.
So let's talk about chemical bonding. We've already learned about two types of chemical bonds. We know hopefully by now that they're what holds atoms in molecules / compounds together. Bonding, what we don't know or what we haven't been told is always going to use valence electrons, which is a keyword from the end of chapter 7. So electrons in an atom can be categorized as either valence or core. The valence electrons are the outermost electrons in the atom, and the core electrons are anything that aren't a valence electron. Atoms are always trying to get 8 valence electrons in their structure. That's like kind of the magic number. It's what noble gases have, which is why it's a very stable configuration. So that's why typically atoms bond together, so that they can get 8 valence electrons. We can use what we call Lewis structures and symbols to kind of keep track of valence electrons and predict bonds. Now, a lot of that's going to be shown as we go through this chapter. So, types of chemical bonds. We've already covered 2 types of chemical bonds. One of them was the covalent bond. And back in chapter 2, we said 2 atoms are going to share electrons when they form a covalent bond. That's not really different still. That's still the same definition, just now we've added a word in between share and electrons. Specifically, the atoms are sharing valence electrons, which is important. The other type of bond we learned about was an ionic bond, and ionic bonds, we said it's the transfer of electrons from one atom to another to form the ionic bond. Now we're just going to add in, sandwich in that keyword valence electrons. Again, it's the valence electrons that are going to be part of bonding or participating in bonding. But most of this is review. It's just the adding in that keyword valence electrons. All right. So let's talk about Lewis symbols. Lewis symbols kind of help us keep track of the valence electrons present in an atom. Again, Lewis symbols are for atoms, so they contain only valence electrons. So when we're writing a Lewis symbol, we only really care about how many valence electrons the atom has. It has to obey what we call the octet rule. And the octet rule states that we can only have a maximum of 8 valence electrons. Hence octet, right? Octa is 8. Which means our outermost electron configuration has S2P6 is the max it could possibly have. And where N is the highest value, right, in the atom. This is mainly due to the fact that noble gases have very, very stable electron configurations, and therefore all other atoms want to have electron configurations like the noble gases. So here are a bunch of Lewis symbols. And so you can kind of see lithium. Ooh, that's a bad color. Lithium only has 1 valence electron. So when we write its Lewis symbol, you see the symbol of lithium, Li, with a single dot next to it. Now that dot is the 1 valence electron lithium has. Now whereas fluorine, neutral fluorine, has 7 valence electrons. And so you see 7 dots around the fluorine atom. So let's look at how to actually draw these.
Okay, so when we want to draw some Lewis symbols, there's some rules that we need to follow. And the first thing we have to do is we have to draw the atomic symbol of the element that we're going to be making our Lewis symbol for. Then we need to know where we can put our dots. Now, each dot represents a valence electron, and we really can only put them in discrete locations around the elemental symbol, right? So if you think about it, these boxes, you're not actually going to draw these boxes. This is just my way of showing you, hey, these are where our locations for electrons are acceptable. In other words, we can't put electrons here or here. When we're drawing our Lewis dot symbols, that is not acceptable. They need to be on kind of the up, down, left, right situations. Each one of our boxes here can hold a maximum of 2 electrons. This is due to the Pauli exclusion principle. Again, the boxes are not going to be drawn, just this is where we can put our electrons. And in each location, we can only put 2 electrons max. Finally, when we're drawing our Lewis symbol, the first thing we need to do once we have our Lewis symbol, elemental symbol written down, is we need to count how many valence electrons that element has. At that point, we start putting them around the elemental symbol. One of the things that you got to be careful about is that we do not make pairs until all the boxes are filled with at least 1 electron. This is a reference to Hund's rule that we learned in the last chapter. Hund's law, it's actually Hund's rule, sorry. And so in other words, I'd put 1 electron here, then 1 electron there, then 1 electron there, then 1 electron there before I start putting any of them next to each other. At this point, now that I have 4 electrons in each location, I would then start pairing up my electrons. And I'd keep adding dots until I run out of electrons to put on the symbol. So let's do some examples here. So let's draw the Lewis symbol for carbon, oxygen, and chlorine. So starting with carbon, we have to write its symbol. I'm just going to write all the symbols right off the bat. So we need to figure out how many valence electrons carbon has. Now, we can do this from the periodic table, and that's probably the easiest way to do it. We know that carbon is in the column that would have 4 valence electrons. So, and if we look at the electron configuration, you can see that carbon only has 4 valence electrons. So again, I'm going to put them in one spot each around carbon. And since that actually just uses up all 4 of my electrons, there we go. This is my Lewis symbol of carbon. Now oxygen, it has 6 valence electrons. So when I draw my electrons around it, I'm going to start, and it doesn't really matter where you start. You can start anywhere you want. I've used up 4. I have 2 more to go. So here is an acceptable Lewis symbol of oxygen. Now, oxygen actually has a number of different acceptable Lewis symbols. I could have drawn this as like this too. This is also totally acceptable for oxygen. Notice that the similarity here is that we have 2 paired and 2 unpaired electrons around the oxygen symbol. It does not actually matter where the paired groups are versus the unpaired groups. As long as you have a total of 6 valence electrons and 2 of the groups are paired up and 2 of the groups are unpaired, that is an acceptable Lewis symbol of oxygen. Chlorine has 7 valence electrons. So when we do this, we go 1, 2, 3, 4, 5, 6, 7, and this is an acceptable Lewis symbol for chlorine. Again, like oxygen, there are actual multiple symbols that would be acceptable. We could have also had it look like this. Really, that where that 1 unpaired electron is, it doesn't really matter as long as you have 3 paired up groups and 1 unpaired group. All right, so if you have any questions, please email me and come to office hours, or we can set up a Zoom meeting to meet in one-on-one, and I'm happy to help you with anything if you're confused.